Hello folks, we come to the part 2 video of this miscellaneous exercise, and let's see how we can solve. These are all crucial problems, and let's see how with what technique we are able to solve this problem. Let's take. We have this fifth problem which says that cos inverse of 4 by 5 plus cos inverse of 12 by 13 is cos inverse of 33 by 65. As usual, we are going to consider the correct right triangles, and from there we are going to check out how we can get these values. So right away, let's consider the right triangles. Consider the right triangles. We have two of them here. Yes, there is a theta because it's cos 4 5 3 4 5 is your first right triangle. So here we have cos theta is 4 by 5, so theta is cos inverse of 4 by 5, and tan theta is 3 by 4. So theta is tan inverse of 3 by 4, and this one we could call phi 12 by 13, phi of course. So cos phi is 12 by 13, and phi will become cos inverse of 12 by 13 tan phi will be 5 by 12, and phi will become tan inverse of 5 by 12. Consider the LHS. LHS for us, cos inverse of 4 by 5 is theta, right? And cos inverse of 12 by 13 is phi. So theta plus phi. Theta is tan inverse of 3 by 4, and phi is tan inverse of 5 by 12. There's so many properties in terms of tan. That is why we try to revert it back in terms of tan. So many formulae, so many properties for tan. That is why we are eager to get back to tan and try to work with tan. That's how whatever ratio we are given, we try to come back to tan and try to be in tan so that you can use those properties, right? So tan inverse of A plus tan inverse of B is tan inverse of A plus B by 1 minus AB. So by that property, this will become tan inverse of 3 by 4 plus 5 by 12 by 1 minus 3 by 4 into 5 by 12. You can have it equalized into 3 into 3, and this can be maybe 12 into 4. And let's see how this can get simplified. This will become tan inverse of 9 plus 5 by 12 over 12 into 4 is 48 minus 15 by 12 into 4. Let's have it simplified. This is tan inverse of 9 plus 5 is 14, and here 48 minus 15 means it's 3, and 33 by 4 divided by 4. So divided by 33 by 4 means multiplication by the reciprocal. So this will become tan inverse of 56 by 33. Okay, so we need to consider the right triangle. We'll do a little side business. Consider the right triangle alpha here, 56, 33 and 65. We can check. We can actually check the triplets. We can check 56 squared plus 33 squared, whether it is 65 squared or not. It is. So this is a triplet. So like that, we know that tan alpha is 56 by 33. So alpha is tan inverse of 56 by 33. So this is alpha. But alpha, because we want this in terms of cos. Let's check cos. Cos alpha here is going to be 33 by 33 by 65. Yeah. So alpha can also be called as cos inverse of 33 by 65. This is cos inverse of 33 by 65. The working is shown here. That's how the working comes. Right. And this is your RHS. right? So we required 3 triangles here. Generally we are okay with 2 triangles, but in this case we required third triangle also. Now next one is going to be absolutely in these lines, so it's going to be a little easy for us to do it. Cos inverse of 12 by 13. Cos inverse of 12 by 13 plus sin inverse of 3 by 5 is equal to sin inverse of 56 by 65. Again 3 triangles will be required, so right away we can consider right triangles. That will look like a right triangle. Okay, 12 by 13, so 12 here, 13 here, 5, so that's how the triplet is. So we have cos theta to be 12 by 13, which makes theta cos inverse of 12 by 13, and tan theta is 5 by 12, which makes theta as tan inverse of 5 by 12 also. Now, the next triangle is with phi. Okay, 3, 4, 5. Sin phi is 3 by 5, so phi is sin inverse of 3 by 5. Tan phi is 3 by 4, so phi is tan inverse of 3 by 4. So that's how we have all this ready. Now we consider the LHS. Okay, LHS for us is cos inverse, that is theta, right? First one is theta, the next one is phi. And theta for us is also tan inverse of 5 by 12. I said we are always eager to get in tan. Plus tan inverse of 3 by 4. We are applying the formula. Tan inverse of A plus tan inverse of B is tan inverse of A plus B by 1 minus AB. So tan inverse of 5 by 12 plus 3 by 4 by 1 minus 5 by 12 into 3 by 4. So this into 3 into 3, 12 into 4. So tan inverse of 5 plus 9 by 12, and here it is 48 minus 15 by 12 into 4. So you have tan inverse of 14 by 33 by 4. So you have it divided by, so multiplication by a reciprocal, tan inverse of 14 into 4 by 33. So that is tan inverse of 56 by 33. You can consider the right triangle alpha with 56, 33 and 65. So tan alpha is 56 by 33. So alpha is tan inverse of 56 by 33. Also, what do we require? Sine. Sine alpha is 56 by 65. So alpha is sine inverse of 56 by 65. So this is according to our assumption alpha, but alpha is also sine inverse of 56 by 65. So that's how this becomes our RHS and hence proved. Yeah, that's how it is. Later on it's proved. So that's about this problem. Once we are done with that, we'll quickly move to the next one. It's slightly simpler because we have tan on the right hand side. So let's consider the triangles first. Yeah. Theta, 5, 13, 12. So here sin theta is 5 by 13. Theta is sin inverse of 5 by 13. Tan theta is 5 by 12. Theta is tan inverse of 5 by 12. Then phi is cos phi is 3 by 5. phi is cos inverse of 3 by 5. Tan phi is 4 by 3. Phi is tan inverse of 4 by 3. All this is our prerequisite. Then with this, let's start with the LHS. Consider the LHS. What do we get? Not LHS, RHS. Tan inverse of 5, it's theta. This is phi. So theta plus phi, which is tan inverse of 5 by 12 plus tan inverse of 4 by b. Tan inverse of a plus tan inverse of b is tan inverse of a plus b by 1 minus ab. So tan inverse of 5 by 12 plus 4 by 3 by 1 minus 5 by 12 into 4 by 3. Equalizing into 4 into 4 into 12 into 3. So let's see. Tan inverse of 5 plus 16 by 12 whole by 48 minus 15 by 12 into 3. 112 can cancel. Tan inverse of 21 by 33 yeah, I hope it's correct. 8 minus 5, yeah, 33 by 3. Yeah, I'm checking. Somewhere something is not correct. Let me check once again. This is tan inverse of 5 by 2, tan inverse of 4 by 3, correct? So oh yes, this is 36. All this time we were doing 48. It's in my mind, it's 48. This is 36. So 36, one of the 12s are knocked off. Then 36 minus 15, 6 minus 5, it's 1. And 3 minus 1, it's 21. to 3 by 16. And 4 by 3, it's correct. Oh, what a blunder. This is 20. It's 20. So, 21 by 16 by 3. That's it. Tan inverse of 21 into 3 multiplication by reciprocal. So, that is tan inverse of 63 by 16. That is our RHS. I was carrying on that work which from last two problems that same thing was continuing. So that is there, instead of 20 it is 15 and then it's okay. So anyhow, sorted out. We are getting tan inverse of by 16 which is the RHS, and that's how we prove the result henceforth. That's all about this video. In the next video